What's up guys, my name is Rustagi and today we're going to be doing part 2 of Unit 6. Now this is only for AP Calculus BC students, so if you're an AB, you can move on to Unit 7. Now if you haven't already, please go to the description right now and get my free AP Calculus AB and BC books, and they have everything you need to know to get a 5 and an A in your class. So what are you waiting for? Get it right now. And now let's begin. So the first topic is integration by parts. And this is by far probably one of the most common topics on the AP Calculus BC exam. And this is used when we want to integrate basically the product of two functions. So basically the integral of f of x times g prime of x is f of x times g of x minus the integral of f prime of x times g of x. And in this situation, as you can see, originally we had the product of two functions, and one we denoted as f of x and the other as g prime of x. And then later, we want to find f prime of x and g of x. So f of x should be something that's easy to differentiate, and g prime of x should be something that's easy to integrate. So we can find g of x with that. So this is very important. For example, if we have the natural log function, then we should never make g prime of x be the natural log function, since integrating that is very hard. So now let's look at an example. Let's find the integral of x to the power of 3 times the natural log of x. Now to do this problem, instead of using f of x and g prime of x, I'll be using the same formula still that I just showed you, but instead I'll be using u, which is the same thing as f of x, and dv, which is the same thing as g prime of x, but instead it's dv and u. So u will be the natural log of x, because it's easy to differentiate the natural log of x, but if we made dv be natural log of x, then that's very hard to integrate. So dv will be x to the power of 3. And then using this, we can find that v equals to x to the power of 4 divided by 4. So now, we use integration by parts. So the formula you can see on the screen right now. So we plug everything in. And we get the integral of x to the power of 3 times the natural log of x, which is what we want to find. Now that's equivalent to x to the power of 4 divided by 4 times the natural log of x minus the integral of v du, and v is x to the power of 4 over 4, and then du can be found by differentiating u equals to the natural log of x, and we can differentiate that to get du equals to 1 over x times dx, which means we want to find the integral of x to the power of 3 over 4 with respect to x. So now we can simplify this entire expression to find the integral, and simplifying it gives x to the power of 4 divided by 4 times the natural log of x minus x to the power 4 over 16. And we get x to the power 4 over 16 by integrating x to the power of 3 over 4. Now, let's learn about integrating with linear partial fractions. So sometimes you will have a rational function, right? And you can split it apart into partial fractions. And this is known as partial fraction decomposition. For example, this expression x plus 2 divided by x plus 1 times x plus 3. This can be decomposed to a over x plus 1 plus b over x plus 3. And now, if you multiply both sides by x plus 1 times x plus 3, then you can solve for a and b. Now this is best learned through an example, so let's see one immediately. Now improper integrals involve limits, since they have integration bounds of infinity or an infinite discontinuity. So this is very important. So please memorize these forms, or you can know them conceptually. So basically, if we have a function f of x that's continuous from a to infinity, and we want to integrate for that, then basically you write a limit and you make a variable such as t approach infinity, and then you want to find the integral from a to t of that same function. So now you find the integral from a to t, right? And whatever expression you get, you see whether it converges or diverges. If it converges, then you can find and evaluate the improper integral. And if it diverges, then it means it's divergent. Now for a function f of x is continuous from negative infinity to a, we do the same thing. But now the t that we declare will be at the bottom instead of at the top. Now let's look at more examples. Well, if we want to integrate from negative infinity to infinity, we will now break this integral apart from negative infinity to 0 plus from 0 to infinity. And then we will write two separate limits. So one as t approaches negative infinity and one as t approaches infinity. And then we can get this expression. Now if f of x is continuous, now there's one more form you should know. Sometimes your infinite discontinuity will be in the middle of the integral, such as, let's say we're integrating from a to b, but the infinite discontinuity is at c. So basically you split the integral up. So one goes from a to c and the other goes from c to b. And then you make two separate limits, one for each integral, and one where t approaches c from the left hand side and one where t approaches c from the right hand side. And then you can write this expression. Now let's look at an example. So this is a 1993 AP Calculus BC MCQ. So we have the integral from 4 to infinity of negative 2x divided by the cube root of 9 minus x squared. Well, since this is an improper integral, let's write this with our limit notation. So as t approaches infinity, we want to find the integral of this expression from 4 to t. So to integrate this, we use u substitution. So we substitute u equals to 9 minus 6x squared, which means du equals to minus 2x times dx. So we can substitute both of these in to get that we want to find limit as t approaches infinity of 1 over the cube root of u times du. However, there's one important thing. As I said, this is not an antiderivative. We're finding the definite integral because we have actual bounds. And this means that we must change the bounds since we're using u substitution. So to change the bounds, we simply plug in the lower bound and the upper bound of the integral into u equals to 9 minus 6x squared, and then that will be our new bounds. So we plug in 4 to get negative 7, so that's our lower bound, and then we plug in t to get 9 minus t squared. Now we can integrate this. So basically the integral of 1 over the cube root of u is simply 3 over 2 times u to the power of 2 over 3. And this means we want to find the limit as t approaches infinity of 3 over 2 times 9 minus t squared to the power of 2 over 3 minus 3 over 2 times minus 7 to the power of 2 over 3. And as we can see, if we substitute in infinity for this, right, we can see that we have 9 minus t squared in this expression. And that's going to be approaching a very large negative value. So this integral is non-existent. We cannot evaluate it. Now let's look at another example. Now this is the 1973 AP Calculus BC MCQ. So we want to find the integral from negative 1 to 2 of the absolute value of x over x. So the absolute value of x divided by x to the left of x equals to 0, right, will be negative 1. And the reason is that the absolute value of x is always going to be positive, but then x, that's negative to the left of 0. So we're left with negative 1. And then to the right of 0, this expression, the absolute value of x over x will be positive. However, we can't integrate this expression at 0. So that means we have an improper integral. So we integrate this from negative 1 to 0, and then we add that to the integral of the same expression from 0 to 2. And now we bring in our limits. So the first limit is as t approaches 0 from the left-hand side. And then the integral of that expression from negative 1 to t. Now the second one is the limit as t approaches 0 from the right-hand side of the same expression from t to 2. So the integral of that. So then the first integral simply evaluates to negative 1. And the reason is that absolute value of x over x to the left-hand side of 0 is always minus 1. And then for the second limit, the absolute value of x over x to the right of 0 is always positive 1. But since our integration length, right, the width is 2, That means the second limit is 2. So we can add -1 and 2 to get 1 for the answer. Now I have a very tough exercise for you. The integral of 3x squared times the natural log of x from 0 to 1. And this is a pretty tough problem. Please pause the video and try it. And even after looking at the solution, you guys might need help. So please join the Discord server to ask for help. So basically, we have an infinite discontinuity at 0 because the natural log of 0 just does not exist. So for this improper integral, we make t approach 0. So now we want to find the integral from t to 1 of 3x squared times the natural log of x. And now we use integration by parts to integrate this. So u will be the natural log of x because if we make dv, so u will be the natural log of x because if we make dv be the natural log of x, then that's very hard to integrate. So since u is the natural log of x, we can find that du is 1 over x times dx. And that means dv is 3x squared, so v equals to x cubed. So now we use our formula for integration by parts, which can be seen on the screen, and we can put all of these expressions back into this to find that we want to find x to the power of 3 times the natural log of x, right? We want to evaluate this from t to 1 minus the integral from t to 1 of x to the power of 3 times 1 over x with respect to x, the integral of that. So now instead of finding this a combined expression, we can break this expression apart and separately find the limit as t approaches 0 of x to the power of 3 times the natural log of x minus, and then we can separately find the limit as t approaches 0 of the integral from t to 1 of x to the power of 3 times 1 over x. So then, let's find the limit as t approaches 0 from the right hand side of x to the power of 3 times the natural log of x from t to 1. So we simply substitute in 1 and t into this expression to get 1 times the natural log of 1 minus t cubed times the natural log of t. And we can find that this becomes 0 because the natural log of 1 is 0, and when we substitute in 0 for t cubed, we get 0. So this whole expression becomes 0. Now let's find the limit as t approaches 0 of the integral from t to 1 of x to the power of 3 times 1 over x. So that evaluates to the integral of x squared from t to 1, which is x to the power of 3 over 3. And now we substitute in 1 into that to get 1 over 3 minus t cubed over 3. And since t approaches 0, t to the power of 3 over 3 is simply 0. So we're left with 1 over 3. And that means our final answer is 0 minus 1 over 3, which is simply -1 over 3, which means it converges. Now thank you so much for watching this video, and please don't forget to like, share, and subscribe, since that's going to tell me that you guys are truly enjoying and learning from the books and the videos that I've been making for you guys. And don't forget to join the Discord server to meet other hardworking students that are preparing for various competitions and exams such as the AP exams. And also, don't forget to follow the Instagram if you have Instagram to view educational reels and cool animations. And again, thank you so much for watching this video, and I really hope to see you soon back again on this channel.